Okay, so we're going to do this practice sheet first, and I'm going to give you an example of each, or 3 examples of each, and then you're going to have to do the other on your own. So the first thing it says is to write out the decimal equivalent regular form of the following numbers that are in scientific notation. So basically we're working backwards. We're going to turn them back from scientific notation numbers to regular numbers. What I want you to first notice is that in the first 1 through 6, they are all positive numbers, so they're all going to make bigger numbers. So 10 to the 2 means I'm going to make 10 and draw the decimal to a bigger number 2 places. So that's going to be 1,000. Okay, 10 to the 4 means that I am going to have the decimal move over from the tens place 4 places. So it's basically saying 10 times 10 times 10 times 10, 10 4 times. So if you do 10 4 times, that's going to leave you with 1, 2, 3, 4, adding 4 more zeros. So it's going to leave you with 100,000. This one is 10 to the 7. So that the decimal is here. So it's going to move this way 7 places. So it's going to go 1, 2, 3, 4, 5, 6, 7. Fill in the zeros. So that's 1, 2, 3, comma, 1, 2, 3. Okay, so that's 100 million. All right, and then you can finish over on this side. You've got, actually I lied, there are some negatives in here. We're going backwards, so these are negatives. So we start, the decimal starts here and it's going back 2 places. 1, 2. So your decimal's right here, so it's 0.10. Okay. And then we've got 10 to the negative 5. The decimal exists here, so we're going to go 1, 2, 3, 4, 5. Put your new decimal in, fill in your zeros. So you have 0, 1, 0, 0, 0, 1, a decimal. So it's going to basically, if you write it neater, you can get rid of this 0 once you've moved the decimal over, so it's 0.0001. Okay, just like this one would be the same thing as 0.1. Okay, so then we got 10 to the 0. We don't move it at all. It's just 10. Okay, so now we look at section B, and we've got the scientific notations, and I'll do one from each side. So we've got 3 times 10 to the 2. So that means your decimal's already here. Because it's a positive number, we're going to go in this direction to make a bigger number. So we're going to go 2 places in this direction to make a bigger number. So that makes 300. So that equals 300. For this one, so I'm going to change color, just give us a little color difference. 6 times 10 to the negative 3. So that means it's going to go this way. So we're going to go 6 decimal, because that's where the decimal is, but we're going to move it this way 3 places. 1, 2, 3. So we'll put our dot there. So that's 0.006. See how we made our smaller number. So the negative means you're getting a smaller number, and the positive means you're getting a bigger number. So you can see here we're getting 300, and here we're getting not even a near, 6 thousandths of a number, really small. So then we've got a positive number here, so we're going to go in this direction with the decimal. So 7, the decimal's here, we're going to move it over 4 places. 1, 2, 3, 4. So 1, 2, 3, 4. So it's going to be there. So that's going to be 70,000. Then we've got negative 2. So the decimal's here. We're going to move it over 2 places. So that's going to be 9 point, or just plain 9, because 9.00 is the same thing as 9. Okay, do the other two next. So now we're going to go convert from the decimal form to the scientific notation. So we're going to go from the decimal form to the scientific notation. So we start with 10 to the, or we want to turn that just to 1. So we're going to 1 times 10. And we've got the decimal here. We're going to go this way 1 notch. So it's going to be 1 times 10 to the 1. Okay. And then this is 100. So we start the decimal here. It goes over 1, 2. So 1 times 10 to the 2. Here we've got the decimal here. It's going to go over 1, 2, 3, 4, 5, 6, 7, 8. So that's 1 times 10 to the 8. Then we're going to go the opposite direction. We're starting out with a small number, so now we're going to have a negative exponent. So that's going to be 10, or sorry, 1 times 10 to the negative 1, 1 times 10 to the negative, because it's a small number, 1, 2, 3, 4, negative 4, because the decimal goes behind the 1. Decimal goes behind the 1, so it's 1 times 10 to the 0, because we don't move it at all. We don't want to move it. So it's just 1. Okay, so then we're going to go the opposite here. 400 is 4. We want the decimal to go here. So it's times 10 to the 2, because you have to move it 2 places to get it to behind the 4. We're going to move the decimal here behind the 6. So it's going to be 6 times 10 to the 1, 2, 3, 4. Here we're going to a small number, so it's going to be a negative exponent. So we want this exponent to go here, so it's going to be 1, 2, 3. So it's 5 times 10 to the negative 3. Again, it's a negative exponent because this is a small number. We want the decimal to go between the 3 and the 4, so we go 1, 2, 3. So it's 3.4. Sorry, that should be 3.4. Times 10 to the negative 3. This is also a smaller number, so it's going to be a negative 6.457 times 10 to the negative 1, 2. Just goes after the 6. If I take the decimal all the way to the end of the number, that gives me 6,457. We want a number between 1 and 10. So if I move the decimal here, that's 645. That's not between 1 and 10. If I move the decimal here, that's 64.57. That's still not between 1 and 10. So I have to move the decimal here to get 6.457. And a 6 is a number between 1 and 10. Now for our last one, we move it here. It's a big number, so it's going to be a positive exponent. And we have to move the decimal 1, 2, 3, 4, 5 places. So it's going to be 7.5 times 10 to the 5. And that's the first practice worksheet. Now we're going to move on to the next worksheet. Now this one's kind of a playful worksheet. You have to match the standard form with the scientific notation form. And as you draw a line to match, it's going to go through a number and a letter, and that's going to tell you what to put down in the code box. And so it's going to answer the question. So what we're going to do is, let's zoom in on 7,000. So this one is going to be this one's going to be 7. You want the decimal to go here, so it's going to be 7 times 10 to the 1, 2, 3. So 7 times 10 to the 3. So if we find that on the opposite side over here, it's right here. So I would use your packet your notebook as a straight edge to connect the dots, and you're going to see once the lines connect, that it goes through the letters, the number 7 and the letter E. Down at the bottom of your page, you're going to put the letter E in the 7 box. So then we're going to look at the next one. And that's going to be 7 times 10 to the 1, 2, 3, 4, 5, 6. So that's 7 times 10 to the 6. So we'll find it on this side, which is right here. So I've got to connect the line from here to here. And you can see that the line goes through 12 and A. So down at the bottom of the page. In the 12 box, we can put the letter A. Okay, then we're going to solve the next one. So this is going to be 70. We want the decimal to be after the 7. So that would be 7 times 10 to the 1. So we'll find the match over here, right down here. We'll draw our line to connect. And you'll see that this goes through the letters 15D right there. So you could put 15D down at the bottom of your page. So then we'll keep going, and then like if you get to one that's like this, it's going to be a negative number because it's starting out with something small. So this one is going to be 7 times 10 to the negative 1. So then you're going to match that up. Almost right across. So you would see that this one is 5U. Okay, and that's how you do this puzzle. Hope you find the answer to why couldn't Orgo keep his waterbed a secret.